Okay, so here we go. We are on chapter 6. Now, this lecture is going to be a little different than the ones before. It's not going to be broken down into sections. I think it'd be easier we follow through with just one linear lecture, so this may take a couple minutes more than the previous ones. It's not going to be quite as short, but it's going to cover the same amount of material as previous lectures. So here we are going to be able to define character data types. So the data type character, as you may remember from the very first lecture, is a data type that is able to store small pieces of text. Now, this can be stored in a vector, a list, a matrix data frame, and an array. Characters are distinguished by surrounding the text in quotation marks. So individual elements in characters are known as strings. They can be a letter, a word, or more symbols. If you don't use quotations, then R will not save the string as a character. So here we see on the right that we have two string values. The first one will be hello, the second one will be world. This is typically the first exercise you see in most programming classes, is to get a start on making a program that says hello world. So here we go. This goes ahead and passes those two character strings onto one variable, and the return values are, just as you would imagine, two strings of hello and world. So we verify the type of it. It is indeed a character. But if we were to just type in the word hello with no quotation marks, it would give us an error. Since the object hello is not found, you would have to put it in quotation marks in order for it to return a value, which we see just below. R does go ahead and return that as a character data type. Now, you can use either double quotes or an apostrophe to be able to go ahead and pass character strings. And just to emphasize the point that it doesn't necessarily have to be a letter. It can be a number, it can be a symbol, whatever you put in there, as long as it is in quotation marks, double or single, an apostrophe, it's going to be of type character. So here we have vectors. So creating vectors that contain specific information. You're going to have a variable passed by given the information by a collective vector of x and y. The character vector is the most common data type to store names of objects. So there's going to be times where you have data let's use a very common data set that's used in programming classes and data science. There is one called empty cars, and they have a list of cars, as you may imagine. Here on the right, we can go ahead and pass an example of just some MLS teams, and they will be stored as a vector. So one of the things we want to be able to do within data science is manipulating the characters in the strings. So searching for a value that you know the exact position of, we can use the function substring, open and close parentheses, to find it. The substring function takes three arguments: your data source, the starting point, and the stopping point. So R will look for elements specified by the arguments passed. If we take a look on the right, we have a variable with a character string that contains the sentence, how can we subset a string of characters? If we use the substring function, we pass in character string. That's going to be our data. Our starting point will be the very first element, or the very first character, which is going to be H, and then the stop is 4. If you notice that the return value is the word how and then a space, R also considers the space between words or between letters, if you place it in there, as an element in the character string. Another concept that I want to go ahead and cover is the concept of concatenation. or to combine or collect a series of data points. This can be done using the paste function. The paste takes the variables or sets of data that are desired for concatenation. So very similar to what you imagine from probably doing copy and paste on your computer. Paste is going to pass certain character strings or certain characters that you pass on into an existing string. So on the right, I've put together a couple examples as to how we can go ahead and utilize the paste function. At the very bottom, we see that we want to paste together two different variables of characters, new string and paste example, into a variable called new string example, which will give us, can we subset a string? Yes, we can. Another thing you want to be able to do is creating subgroups of your data. This can be done with more string manipulation using the cut function. The cut function creates bins of equal size and by default in your data, and then classifies each element into its appropriate bin. So this allows for the analysis of individual data. So this is an example of a dataset that's native to R. You can go ahead and import state.x77. This is going to give you the information for 50 states on a couple different metric areas. So what we can do is we can go ahead and subset the data here. If we take a look at the third input line, you see USA income. What we're doing here is that we are separating the column that refers to income from the original data point, which is state x77, and we're going to pass just the income column onto one variable. So notice how we can also specify the column by typing it in quotations. That can either be a name, or you can even use index notation to subset the data frame. One of the functions I want to quickly cover here that you'll get more information in later lectures is a function called head. The head function allows you to take a look at a small subset, and that's going to be the first 5 rows of a data set. So you don't have to import a large table to make sure it's actually represented correctly. You can just take a quick look and see that it is done accordingly. So keep in mind the USA income variable only has income, so the first 5 variables or the first 5 data points you're going to get Alabama, Alaska, Arizona, Arkansas, California, Colorado. Checking the dimensions of this, it's going to be null. It has no dimensions. It's just one column. And just tying it back together about the cut function. To cut the data to create 5 bins of equal size data, we can use cut USA income as the data source. The argument passed in how many bins is next, so that's 5. And you want to include the lowest. True. So you can play around with these settings and the arguments and see how many different ways you can shape your data differently by passing different arguments. So just moving on with manipulating characters and strings, sometimes you want to be able to know the occurrence of an individual or group of values. More than likely, you've probably seen this in the past in just introductory stats. This is one method to just get the mode of a data set. What you want to do here is you can use a table function. It tallies up all the occurrences of each individual value within the variable that you pass to it. So table will go through the data and count the occurrence and display it to you as the result. It's great when you're looking at small to medium data that may contain many values, and you want to get an understanding as to what the distribution may look like and how many of each fall within each value. So manipulating characters and strings with regular expressions. Something you're going to notice is that some people may refer to them as rejects. R does a pretty good job at doing this. Other languages that are pretty good at doing this as well is Perl, but you won't be seeing that just yet. So when you're working with strings, sometimes you need to search for a specific string within certain fields. Since human language can be complex and not follow the same rules each and every single time, doing a broad search can be difficult and return the wrong value. So here's an example from the textbook that you see in the Art of R Programming, a tour of statistical software design. There's a function called grep. What it does is it goes ahead and grabs a subset of the data that you specify. Now, taking a look here, we can take a look and see that we are looking for the values A and U within the vector file on the right. Now, this reports that elements 1 and 3 of equator, North Pole and South Pole, that is equator and South Pole, contain either an A or a U. A period here represents any single character. So here's another example of doing it in another way. You can use grep with O and O period E in quotation marks to look within those same vector, which you're going to see the elements that appear besides O and E. Moving forward with this, we see that here we try to find a 4-letter string consisting of an N and ending in T. The period in this example isn't considered the period in the sense of a component to search for. This is actually an example of meta characters. Meta characters are characters that are not taken literally. In this case, the period is a meta character. So R is not gonna hold this as a value to search for. It's actually going to be a tool used for searching for multiple values within a substring. So a period in the beginning of grep is a command to tell R any character. So you may have seen this in other languages if you have experience with them. If not, something that is tossed around loosely is that this is a wildcard character, which allows you to go search for any character. Adding quotes will not return the correct value since you will need to escape the characters for the period if you want to look for objects that contain a period. So escape characters are used to tell R that a meta character is going to be used, but instead look for it. To escape the meta character of the period, you need to add backslashes and the period, all in quotation marks. The backslash in this case is also an escape character, which is why there are 2 for the regions expression. If you were to add just 1 backslash and 1 period, it does not look for the characters that you think you're looking for. The true way to escape it is by adding 2 backslashes that we see here on the right.